Okay, let's study the basic application skeleton. We start using GLFW library with GLFW init function. If it fails, we should abort. The next thing is window. GLFW gives us cross-platform abstract way to create windows. GLFW create window function takes window width and height and Windows title. Let's just leave two other parameters as 0. And if window creation fails, we just have to abort. The good style of programming is to call GLFW terminate function before we exit. The next thing is context. As I said before, each OpenGL application has its state within its context, and by calling this function we associate the Windows context with the current one. To be able to process events like keyboard events or mouse events, we need to create the event loop. The user could close the window anytime, and we should be able to handle this gracefully. The function window should close is a specific library function to test for this case. One small final touch is to call terminate function in the end. Now we're done with all boilerplate code and can do actual OpenGL coding. To fill the screen with color, you specify the color with the GLClearColor function. It takes normalized values from 0 to 1 for each subcomponent. And to actually clear the screen buffer, you call the GLClear function with a flag GLColorBufferBit. This is required because in OpenGL there are many buffers, but right now all we need to clear is actual color pixels on the screen. The swap buffers call presents the rendering to actual window. OpenGL renders current frame to a off-screen buffer, and to present it we need to call this function. To process the current events, we call poll events. It is an important part of the application's heartbeat. Now we have minimal viable application to run. Let's just adjust a clear color a bit and run it. Whoa, we can fill the screen with solid color. Well, that's something to start with. Okay, let's summarize what we learned about GLFW skeleton. We init the system with init function, then we create window with createWindow function, and make its context current with makeContextCurrent for this window. Then we start the run loop and poll for window should close event. And inside this loop we swap buffers and poll for new events constantly. Afterwards we call GLFW terminate. The application is spinning inside the event loop, processing the user input and preparing the next frame to display. The OS collects all user input events, like key presses and trackpad movements, and put them into the event queue. It expects us to empty the queue periodically to have a responsive application. The app itself prepares the next frame buffer for the OS to be presented on the screen in the next refresh cycle. Now the screens refresh at 60 Hz, so we have only 1 to 60, around 16 milliseconds to prepare the next screen frame. Let's adjust our code to make the animation. The simplest animation we can do is to toggle the clear color to make each frame look different from another. So, when the next frame will be presented on the screen, it will be different color. Let's draw some geometry. To ask OpenGL to draw a triangle, we use construction GLBegin with flag GLTriangles. Now OpenGL expects at least 3 vertices for one triangle. We finish sending the geometry with GLEnd function call. Now let's provide the vertex data. As you may remember, OpenGL uses normalized device coordinates, so let's put some points on the screen relative to this center point. GL vertex 3f means that we provide 3 coordinates x, y, and z for each vertex, and the format is a floating point. As you see, we give negative x values for the point that is to the left from the center and negative y values if it's in bottom. So, if we render this, we will see this beautiful triangle right in the center of the screen. Now let's make some colors. To do this, we need to specify the color information before the vertex information. We use function glcolor3f. This also means 3 floating point numbers for each subcomponent, red, green and blue. By default, the OpenGL machinery will take those color values for each vertex and interpolate them smoothly across the triangle. Well, I don't like this green background. Let's just change it to white. To do this, just simply edit the clear color line with one for red, one for green and one for blue subcomponents and see what's happening. Yeah, now it's better. We see the smoothly blended triangle. Okay, let's summarize this OpenGL skeleton app. We update the screen every time inside the loop for each frame. We start from clearing the screen with glClear function. Previously we set the color with glClearColor function. Then, inside the scoped glBegin and glEnd pair functions call, we update the screen by providing the new geometry. This is simplest and old-school way to do things in OpenGL. In next chapters, you'll learn about shaders and modern pipeline. It's very flexible and powerful to create amazing real-time 3D graphics and effects. But before this, let's dive into the matrices and 3D rotation formulas.